We're now going to talk about the binomial distribution. And before we do that, I need to talk a little bit about combinations. Combinations and how to calculate them on your calculator. Okay? So the idea of a combination here is, let's say our class had 30 people, and I was going to choose 5 people for a study or for a committee or something like that. And so I'm curious, how many ways can I choose 5 people out of 30 people? Okay, so how many ways can you choose 5 people from a class of 30 people? Okay. And so the way that you do this is there's a button on your calculator that can do it. And so I'm going to show you how to do it on your calculator. And I'm going to encourage you to please use your calculator to do this. I don't have a TI-30, but I do have the graphing calculator, so I can show you on that. And I can kind of explain how it's done on a TI-30. But I'll also show you where this comes from. I'll show you how to calculate it by hand as well, so you can see where it comes from. But you don't have to calculate it by hand. You can do it on the calculator, and that's fine with me. Okay, so the way that you denote this, so a combination sometimes is denoted as N choose R, NCR. And in fact, I don't know if you can see it on my calculator, but I actually have a button that says NCR. So one nice thing about this calculator is that the combination button is actually a button that you push. You don't even have to press second or anything. It is right there on the calculator. Okay? So what I would do, if I want to know how many ways I can choose 30 people out of 5, the N here is the total number of people, and the R is how many people you're going to choose. Okay, so it would be like, let me erase this. It would be, I would write 30 choose 5. Okay, so how many ways can I do it? Like when you first think about it, you might think maybe there's 6 ways, because you can take 30 people and divide them into 6 groups of 5, right? But that is not what's going on. So 30 choose 5 is asking all the possible groups of 5 people that you could draw out of your population. And so to do it on this calculator, you just type 30 and then hit the NCR button, choose, and then hit 5. 30 choose 5. That easy. And you press equals. And look at that. There is 142,506 ways to do that. So 142,506 ways. And so one thing you learn is that these numbers can get very, very large. There are many, many ways of pulling 5 students out of a class of 30 students. All kinds of combinations, in a sense. And so... one way you can think of this is how many possible samples you could draw out of a population of 30. If your population only had 30 observations in it and you were drawing out samples of size 5, there'd be over 142,000 samples that you could draw out. So it's mind-boggling, really. So if you have a graphing calculator, and some people do have these if they've taken like a pre-calc class or something in high school. The way that you would do this on the calculator, you'd type 30 in there, and then you would hit the math menu, and then you would go over to the probability menu, and then you'd hit 3 for NCR. And then there it is, 30 choose 5. Just like that. That's how it is on this calculator. Enter 142,506. So I don't know if you can see that. But so you can see this one's a lot more work. This one has a button directly on the calculator. This one you have to go into the menus and find it. And it's on the math menu. I'll show you one more time. So you hit the math menu and you go to probability, hit 3, and then here it's 30 and go over, choose 5. So I guess this one you don't have to put 30 first. You just plug them in like that, hit enter, and then you would get it. Okay, if you have a TI-30, a lot of people have that because that's a calculator that they use in schools. You should have a button that says PRB. That stands for probability. And if you hit on that, then you should see a little menu that has NCR, and you would go over, click on the NCR, and that's how you would get the button. Okay. I meant for this to be parentheses like this. Sorry. That was probably very confusing. So I'm putting the NCR inside a set of parentheses. Okay. So now what I want to do here is I want to show you how you can do this by hand. Okay. It is possible to do this by hand. So the formula, and maybe what I'll do is I will get another sheet of paper here. So the formula here is the following. N choose R is equal to N factorial over R factorial over N minus R factorial. So this is what it looks like. Now you might wonder, well, what does factorial mean? Well, what that means, for example, if I have 5 factorial, what that means is I'm taking 5 times 4 times 3 times 2 times 1. So you're taking, starting with the number here, all the way down to 1, and you're multiplying them all together. So this would be 20 times 6, and you would get 120. So 5 factorial would be 120. Okay, so that's what factorial means. So if I have so we'll do an example. I'm going to take 30, choose 5. Okay, so what I would do is I would have 30 factorial on top, and then 5 factorial on bottom, that's the R, and then 30 minus 5 factorial. So it'd look like that. But if I simplify this, then you can see what's really going on. And 30 minus 5 is 25. Okay? And so what's really going on is you're doing the total number of people, or like if it was a classroom of 30 factorial on top, and then on the bottom you have 2 factorials. One is the R, in this case 5, and the other one is however many remain. Right? So 5 factorial, 25 factorial. If this were 30 factorial, like 30 choose 10, this would be 30 factorial, 10 factorial, 20 factorial. Okay? And so that's what it looks like that. And so now, if I were to write this out, I would have like 30 times 29 times 28 times 27 times 26. And then I'm going to do this on purpose. I'm going to write times 25. And then instead of going 24, 23 on down to 1, I'm going to just say 25 factorial, which is 25 on down to 1. The reason for doing that is on bottom I have 5 factorial and 25 factorial. So I'm going to do the 5 times 4 times 3 times 2 times 1. And then I have 25 factorial. And now you can see times 25 factorial. So now you can see that this is going to cancel out like that. And I'm left with this. So now I'm going to be able to get everything else in the bottom to cancel out. So the 5 here will cancel out with the 30 and give me 6. The 4 cancels out with the 28 and gives me 7. The 3 cancels out with the 27, gives me 9. And the 2 will cancel out with the 6 or the 26, and I get 13. And so what I get here is 6 times 29 times 7 times 9 times 13. And you're going to get a product of numbers in the end, and this will be 6 times 29 times 7 times 9 times 13. And I get 142,506, the product of those numbers, which you should recognize as the combination. Okay, so that's kind of how it's done by hand. So I'll do another one just to kind of show you how easy it can be. So like if I wanted to do 10 choose 3, let's say. Well, this would be 10 factorial on top, 3 factorial, 7 factorial, right? And then I would have 10 times 9 times 8 times 7 factorial, and then 3 times 2 times 1 times 7 factorial. These would cancel out. Now the 3 will cancel out with the 9. The 2 cancels out with the 8. Gives me 4. The 1 is just stays there. And then I get 10 times 3 times 4. And it's 12 times 10. So 10 factorial is actually, 10 choose 3 is actually 120. And we can check it here. So here is 10 choose 3. And I get 120. Okay, so that's the idea of combinations. So it's important for you to be able to do these on your calculator. And I encourage you, just do them on your calculator. You don't have to do this every time, because we're going to be doing a lot of combinations, and this would get very time consuming. And I don't want you to lose the sight of the forest for all of the trees, okay? So let's just do a little bit of practice, and you use your calculator, figure out how your calculator works, and see if you can find each one of these combinations. And by the way, I guess I've done the first one, 10 choose 3. How many ways are there to choose 3 out of 10 people? So you can start with number 2 and go ahead and do 2, 3, and 4. So go ahead, press pause. When you're done, start the video up, see how you did. Okay, so let's see how you did here. So the first one, of course, is 10 choose 3, which is 120. So this next one is 25 choose 7. So 25 choose 7, and I get 480,700. 480,700. That's how many ways there are to choose 7 out of 25. Amazing. So let's see. How many ways are there to choose 15 out of 75 people? And as you can see, these get very much larger as the numbers get bigger. So this is going to be out very, very large. 75 choose 15. And this actually says 2.28, all of this times 10 to the 15th. So let me actually show you what this means. I'll grab this sheet. So the answer that I got here, 75 choose 15, was like 2.28001268 times 10 to the 15th. So this is scientific notation. So what this means, 10 to the 15th, it means move the decimal point over 10 places. 15 places. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And now that's 9. Now I'm going to have to add a 0. So that would be 10, 11, 12, 13, 14, 15. So I'm adding 1, 2, 3, 4, 5, 6 zeros. So what is this? 2002. Well, I'm not even going to say, I'm not going to put the comma there necessarily. So let me rewrite this. It's a very, very large number. it would look like that. So 100,000, million, billions, trillion. So 228 trillion, 12 billion, 687 million ways to do it. And this actually lost some accuracy, so there was probably some more in here, but it couldn't fit it on the calculator screen. But that's only 75 choose 15. So you can imagine how big these would get. Like out of a population of 3 million in the United States, choose 500. And that, I mean, it's just mind-boggling how big that could be. Okay? You can't even conceive. So this last one, how many 5-card poker hands can be made from a deck of 52 cards? Okay, so 52 choose 5 is what you would do. Out of 52 cards, choose 5 for a poker hand. And you get 2,598,960 different poker hands. So there's like 2.5 million possible poker hands in a deck. And there's actually four royal flushes. So the probability of randomly picking out a royal flush would be 4 over this 2,598,960. So I can do it. 4 divided by the answer. So very, very small. Again, it's in scientific notation with a negative exponent. Okay? So that's just combinations. And the thing that I want you to get here is just to be able to like take 25, choose 7, and be able to get the combination. Okay? And the reason for doing this is it's going to be part of a bigger formula. So you actually are going to be typing it into the calculator. You won't even see how big these are because you're going to multiply it by something else, and it's going to balance out to a kind of a normal probability. So, and that's where we're headed with this.